Hey everybody, so in this video I will be going over the very easy crypto challenge small steps from the Cyber Apocalypse 2023 CTF from Hack the Box. I've already downloaded the files and unzipped them, so let's just go ahead and jump right in. We get these three files: a README file, a server Python file, and a solver Python file. If we look at the README, it essentially just tells you what all the files are. Also gives you a hint for the challenge. And if you look at the solver, as stated in the README, this is kind of a template that will let you use Pwn tools to connect to the remote instance. If you're not familiar with Pwn tools, it is a Python package that has a lot of useful features for CTFs and the kind of challenges that are typically in CTFs. So it's pretty cool that they gave you this. If you're not familiar with it, definitely it's good to use this. Even just this little bit here, just understanding how to connect to a remote, and then how to send and receive lines. Because in challenges, a lot of times for some of the crypto ones, you're going to need to brute force something, so you have to send and receive a whole bunch. So this makes it essentially easy and possible. Well, not that it's impossible without it, but it makes it a lot easier. So it's definitely something you're going to want to use. And even if you just use this as a template and cut and paste and stuff, it's really handy. So it's pretty cool. They kind of helped put that in so that you can figure out what to do. Anyway, the server Pi is the source code for the instance that's running, which we're going to connect to and get the flag from, which if we see in the main loop here, we're essentially just have this menu. Really the only function in the menu, or the only choice in the menu that we're going to use, is get the encrypted flag. So we see what happens is they create an RSA. When you choose E, this RSA encrypts the flag, and then it gives you back the public key, the private, or the public key, the N and the E values for that, and what the encrypted flag is. So let's go ahead and just connect to the instance so we can get those values. And there we go. So if you're not familiar with RSA, really the way you would want to go about this challenge, because I know a lot of people, if you're watching this video, right, you're probably pretty either new to CTFs in general or just the cryptography challenges. So you might not be familiar with RSA at all. And I'm not going to really go over RSA because there's tons of videos on the internet, and they're going to do a way better job than I would. But if you're trying to figure out well, how would I learn, or how would I have known what to do in order to solve this challenge, even just as a beginner where you don't really know stuff about RSA? Well, they gave you this hint here. And it says the implementation is textbook RSA. So you could look up, what is textbook RSA, and learn a little bit about it that way. And then you see that except for the value of E. Well, that's probably what the flaw in this setup is because they're using a different value than E than what it sounds like the normal textbook is. So there probably is some kind of inherent weakness in that potentially. And the way another way to if you sort of understand what RSA is, if you see this modulus here, it should be 512 bytes, right? We're multiplying two 256-bit numbers together to get this in value, so it should be 512 bytes. Oops. It helps if I knew how to type and open and close brackets correctly. Yeah, so 511 bytes. And for reasons I won't go into, this here should most of the time be a number very close to that in size. But we'll see in this challenge, it is actually, I did it again. Sorry, it's like my microphone is covering my keyboard, so I can't look down. We see it's only 475 bytes. It's off by 2 because when you're converting to binary, the string has a 0B in front of it, and so we don't want to count that. But anyway, so what that means is what's most likely to have happened here when we have a number that's small like e. So in RSA, you're taking the plain text and you're raising it, converting it to a number and raising it to the power of 3 modulo this n. Well, if our original message isn't very big, like say it was the number, let's just say the number 42. We're going to raise that to the power of 3. Well, see, we only get, 74,088, but our modulus is this ginormous number. So if you think about it like that, if we were trying to encrypt the message 42, it doesn't matter what our n is. Basically, if it's bigger than this number here, like it could be, 500 bazillion times bigger than this. It like really doesn't matter. Like, so essentially that's kind of like the n is pointless. So what makes kind of RSA, one of the things that makes it secure is it's like really easy to take nth roots of numbers over the entire integers. Like if, we could find the cubed root of this like very efficiently, but it's not easy to take nth roots of numbers over the integers modulo some number. So if we can't use all the integers, it's hard. And essentially when our modulus is so big that we never overlapped it, it's kind of not doing anything. So we're essentially working over all the integers. You can think of it that way. So this long rambling thing I'm babbling about essentially just means if it wasn't big enough to wrap around the modulus, then all we have to do is take the cubed root of it, and cube roots are easy to take. So this should be easy to solve. We just need a way to take a cube root, and there's not really, like if you try the kind of normal way you would think of it, and here, let me just say CT for ciphertext, and if we were to try and take the 1/3 root, which is the cube root, or raise ciphertext to the power of 1/3, which is taking the cube root, we get this back, which essentially this number is too big, so it's just converting it to a float and doing all that stuff. So we need an actual integer. So there's not really a good way in kind of regular Python to do that. You can write like a binary search and do it really simply. Otherwise, you can import some other packages like Simpy or SymPy. I don't know how you say any of those. It's like a symbolic math package, which has a lot of handy functions. Like in that one, there is, I think it's just from the thing, import integer, I think it's integer nth root. Okay, so then we could say integer nth root of the ciphertext. We want the cubed root, and we get this number back. And this true here is essentially just saying that it's actually a perfect cube. So if we had, say, like instead of ciphertext, it was like a number that was like 1 bigger, right? So now it's not a perfect cube. It gets the same number back. Essentially, it's just truncating it to an integer, and then it tells you whether or not it was actually a perfect cube root. And I do believe that actually in normal Python, you could do like, I think it's libnum import, I think it's just nth root, in root, maybe. In root. Oops, well, that's the same thing. I have to tell it what root. We want the cubed root, and we see we get the same number. Now this works the same way, I believe, where it just truncates it, but it doesn't tell you whether or not it's a perfect root or not. So if you had like, instead of that, it was 4, so now it's not a perfect cube root, we get the same, right? Because it's doing just what Simpy did and truncating it. Anyway, So once you get the cubed root of that number, now we just need to convert it back to a message. And we can see here they use the crypto util number bytes to long in the encryption. So we just want to do the opposite. So we would say this is the PyCryptoDome package. If you're not familiar with it, definitely something you want to use for, it's used a lot in like cryptography stuff for Python. So definitely something you want to install. We would say long to bytes, and we get the flag back. So hopefully that made sense. So this is like a pretty kind of gateway challenge into RSA. And so like, if you want to keep doing cryptography challenges, I definitely would recommend just learning learning how RSA works, getting like a feel for it and stuff, because a lot of the easier crypto challenges usually involve RSA. So yeah, anyway, I hope that kind of made sense. You got something useful out of that. If you did and wanted to hit like or subscribe or any of those things people are always telling you to do, it actually is kind of helpful, makes me feel good about myself, so anyway, yeah, thanks for watching and take care.